Every electronic device you use today is built on one hidden idea: circuit theory. From smartphones to satellites, everything depends on predictable electrical behavior inside circuits. In this video, you'll learn what circuit theory actually is and why it is the foundation of all electrical and RF engineering. Circuit theory is the study of how electrical quantities, such as voltage, current, and resistance, behave in interconnected networks of components. It provides a mathematical and conceptual framework that allows engineers to predict how a circuit will respond under different conditions without needing to physically build it first. At its core, circuit theory simplifies real electrical systems into models that can be analyzed using defined rules. These models help engineers understand how energy moves through resistors, capacitors, inductors, and sources in a controlled and predictable way. Without this abstraction, modern electronics design would be extremely complex and inefficient. Circuit theory is not just about solving equations, it is a structured way of thinking about electrical systems. It allows engineers to break down complex devices into smaller parts, analyze their behavior, and then reconstruct the full system behavior from those individual interactions. Circuit theory exists because real electrical systems are too complex to analyze directly at the physical level. Electrons move according to electromagnetic laws, but solving full physics equations for every circuit is not practical in engineering. Instead, circuit theory provides simplified models that still produce accurate and useful results. By assuming conditions such as lumped elements and ideal connections, engineers can focus on relationships between voltage and current rather than microscopic particle behavior. This abstraction makes it possible to design circuits quickly and reliably without simulating every physical detail inside the materials. This approach allows engineers to scale from simple circuits to extremely complex systems like communication networks, power grids, and integrated circuits. Without circuit theory, modern electronics design would not be computationally or conceptually manageable. Circuit theory describes how electrical quantities interact in a system over time and under different conditions. It defines how voltage drives current, how resistance limits flow, and how energy is stored or dissipated in components like capacitors and inductors. It also introduces rules that govern these relationships, such as conservation of energy and conservation of charge. These rules allow engineers to analyze any circuit systematically, regardless of its complexity, as long as it can be represented using circuit elements. More importantly, circuit theory provides a universal language for electrical engineering. Whether designing a small sensor circuit or a large RF communication system, engineers rely on the same fundamental principles to ensure correct and predictable behavior. Engineers use circuit theory as the first step in almost every electrical design process. Before building hardware, they create schematic models and analyze them using circuit laws to predict performance. This helps identify potential issues early and reduces the need for expensive physical prototypes. In practice, circuit theory is used alongside simulation tools to validate designs. Software like SPICE allows engineers to apply circuit theory to complex systems and observe how they behave under different conditions. This combination of theory and simulation is essential in modern electronics design. Even in advanced RF systems, circuit theory remains the foundation. Although electromagnetic effects become important at high frequencies, the underlying circuit model still guides the design of amplifiers, filters, and transmission systems. Understanding circuit theory is essential because it forms the foundation for all other topics in electrical and RF engineering. Without it, concepts like AC analysis, impedance, resonance, and signal behavior cannot be properly understood. Every advanced system eventually reduces to circuit behavior at some level. Whether analyzing a wireless communication system or a power converter, engineers rely on circuit theory to explain how and why the system works. By mastering circuit theory, you gain the ability to understand, predict, and design electrical systems with confidence. It is the starting point of all serious work in electronics and the bridge between basic electricity and advanced RF engineering. So today, we learned that circuit theory is the fundamental framework that allows engineers to model, analyze, and understand electrical systems in a structured way. It transforms complex physical behavior into manageable mathematical models that can be used to design everything from simple circuits to advanced RF systems. In the next lesson, we'll explore lumped versus distributed systems and understand when circuit theory models start to break down at high frequencies. If you found this useful, like the video, subscribe, and follow for the next lesson.